Week 13, Section 2, Swyk 2. Now, to refresh your memory about which quadrants are which, I would like to remind you how to spell the word quadrant. Capital C, actually for you it would be like this. Capital C, W-A-D-R-A-N-T. Quadrant. Yes, I know that's my dumb way to help you remember that it goes in order. 1, 2, 3, 4, like a capital C. Now, they like to use, in Math Excel, they like to use Roman numerals. So they've got I, and IV, in case you're losing fluids. So, 1, 2, 3, 4. Question 5. For the angle, state in which quadrant the terminal side lies. We know where the initial side lies because the initial side is always pointed at 0. It's the terminal side of the angle that we... So there's your 139 degree. That's approximate, obviously, because it's not perfect. 135 is smack dab in the middle of quadrant 2, so it's 4 degrees past that. So we are looking at something in quadrant 2. When you get to 6, it says name the quadrant in which the angle lies. They got 770. So I did this. I subtracted 360 2 times. That gave me 50 degrees, which means I know that even though we went around the circle once, twice, and then another 50 degrees, that's where 770 is, we still landed in quadrant 1. So, question 7. Do we have a question? Ah, gee whiz. I forgot about question 8. Question 7. Find the exact values of the cosine and sine of the angle. So they give me 150 degrees. I drew a circle. Not my greatest circle. But 150 degrees is approximately in the location I indicated right here. 30 degrees shy of 180 degrees. We want the x value and the y value. Well, remember, they go in order, right? So negative 1/2 is here. Negative radical 2 over 2 is here. It ain't negative 1, so it has to be the one that's missing, which is negative radical 3 over 2. And you can see down here that they go one step further and they say, find the decimal equivalent of that. Negative 0.87 is the decimal equivalent. I know that because I typed it on the calculator. You can do the same. But the y value as you come over here is the very first mark up the scale of my axis. You know how I've said they go in order, right? So it's the very first one, which is 1/2, which means that the decimal equivalent is 0.5. Pretty easy stuff. But we are finding a place on the circle. Go back to one of the previous unit circles that I drew, okay? And see what's going on with that, and where you should be at, because you should be at one of the nice locations. Using my pictures before would help you because it's got the marks like, you know, the 45 degrees and the 30 degrees and the 60 degrees, and so you can easily see where you're at, the 90, the 120, the 135, the 150, the 180, and so forth. I better pause and do this question, figure out what it is before I answer you. All right, I changed my mind. We'll just do this one together. I won't even write anything down until now. So they've given me this picture, and they've indicated that they're moving in a counterclockwise or a clockwise direction. So this is a negative angle. I don't know. They might ask me for the angle, but it looks like they're going to ask me for 6 trigonometric function values. We talked about in a previous video how cosine goes with the x value and sine goes with the y value. Okay, in a minute we're going to figure out the tangent because we haven't talked about that. But it looks like they asked me about the sine of the angle first. All right, that's the y value. Then they ask me about the x value. Now they happen to be the exact same thing, so I am going to zoom in on this because I want you to realize that we're dealing with a triangle, right? In that triangle, we have a side length, an x value side length of radical 2 over 2, and a y value side length of radical 2 over 2. Remember, from this angle, this is the opposite side, and this is the adjacent side. So the tangent, right, the tangent of that angle, whatever that angle is, I know it's 45 degrees, or pi over 4. But we take the y value and we divide by the x value. Well, back in middle school, I think you learned that the division is the same as multiplying by the reciprocal. Right, so you take the, they said stuff like keep, change, flip. But that's going to cancel with that. What am I left with? That's right, folks, you're left with the number 1. That's the tangent. So, what are the tangents of the other spots on the circle, the other ones that we haven't talked about, Maybe I should move this up. So the popular angles I've got listed here in quadrant 1, 30, 45, and 60. Well, might as well throw in, let's throw in 90 while we're at it, right? That's the 0.01. Probably should have mentioned this one before now, too. Let's go with the 60 first. So the tangent of 60, that's the green one. Y divided by x, which we know is the same thing as y times the reciprocal. So the 2's cancel, I get radical 3. That is approximately 1.73. Now, I don't care that you know the decimal. What I care that you know is that it's bigger than 1, which makes sense because the angle is steeper. The line is steeper than the blue one. The slope of 1 going right through the diagonal of quadrant 1, that makes sense. Positive 1 slope. The rise and the run are exactly the same. Okay? Now, you come down to the 30 degree. Okay, and we know that things are reversed, right? Tangent 30. We have y divided by x, which is y times the reciprocal. This time the 2's cancel, leaving 1 over radical 3. Now, technically, that is correct. But math teachers from a very old process, they love to rationalize denominators, and a lot of them make you do it. Math Excel definitely makes you do it most of the time. So rationalizing this would be to multiply the top and bottom by radical 3 so that the denominator ends up being a nice number. So you will often see that quoted as radical 3 over 3. Now, I know it's the same thing as 1 over radical 3, but they don't like seeing radicals in the denominator. It used to be that we needed to do that because our calculators, we didn't have the technology to divide by a nasty, ugly decimal, but we've got it now. So it's a little bit of an outdated process, but nevertheless, you'll see it everywhere, so might as well teach you how to do it, even though I don't totally agree with it anymore. However, the approximate value for that is 0.577. Now, do I need to know that number? No, but I do need to know that it is smaller than 1, which makes sense because the line is more shallow than the blue one. So, these are the popular slopes. We've got radical 3, 1 and radical 3 over 3. Those will come up time and time again. You're going to do a lot of this. I mean a lot of it when you get to trig next year. Now you notice that the black one that I drew in for the 90-degree angle. Well, we know that the x value is 0. That's the cosine. We know that the y value is 1. That's the sine. But what about the slope? The slope, the tangent of 90. Well, remember, there is no slope. On a vertical line, there is no slope. It's undefined. I like to think about it like you're skiing down a mountain, okay? If you were skiing down a mountain and suddenly maybe you took a wrong turn and you went off a cliff, there's no slope underneath your feet. You are falling to your death, okay? Not a good thing. That's not the same as a slope that is 0, okay? Just to remind you, so there are actually 2 places on a circle, the top and the bottom, that have an undefined slope. But what about these? These are the ones that have a 0 slope. 0 slope. So in terms of skiing, that's like cross-country skiing, where you actually have to do all the pushing. Not a lot of chance of you dying when you're just pushing yourself. Okay, that's not the same thing as falling, right? Okay. So, back to this question. We found the tangent, right? We divided them. We found out that the slope was 1. All right, so now we need the reciprocals based on what we know. For instance, tangent goes with cotangent. But guess what? When you take 1 over 1 and flip it over, you get 1 again. That's kind of boring. Sine goes with cosecant. Remember I said that they start with the opposite letter? So if the original one starts with S, then the reciprocal trig function starts with C. Okay, so radical 2 over 2. Remember, if I find the reciprocal by flipping it over, oh, but they want me to rationalize it. 2 radical 2 over radical 4, which is 2 radical 2 over 2. And you can only cancel out things that are either both on the outside of a radical or both on the inside of a radical. Do not try to cancel one inside of a radical with one outside of a radical. That's not true. So we do end up with a square root of 2 for this answer. Guess what? We don't need to repeat that process again. We know it's going to happen exactly the same way when we go from the cosine to the secant. You're going to get radical 2. So we don't need to duplicate that. Once again, way too long. Sorry for taking up so much of your time. I hope it was slightly entertaining. Bye.